Okay, so today's problem is that chocolate distribution problem. Here, the problem is that given an array of positive integers where each value represents the number of chocolates in a pocket. Each pocket can have a variable number of chocolates. There are m students. The task is to distribute chocolate pockets among m students such that each student gets exactly one pocket. The difference between maximum number of chocolates given to a student and the minimum number of chocolates given to a student is the minimum. Return the minimum possible difference. Here, the scenario is that we have given an array of integers, okay, that may have few students will get this amount of chocolates and few students get this amount of chocolates like this way, and we have given an array m, okay. Here the size is 5, so we have to find it out the difference between the minimum and maximum number of chocolates we have given to the students, and the difference should be minimum. Okay, so here it is so simple. The first in the first go we just sort it out the given array. After that we just find the difference between first and the fifth element, fifth student. If the difference between that first and fifth student is less, then we have to store it in our answer, right? Like this way we can sort it out our answer. So for this, the first element is always 0, right? And the fifth element is nothing but, as you can see it here, I have taken the same example. I have sorted it in ascending order. These are the index for that. This is the array length, and this will be our m value. Okay, so the first index is always zeroth index, and the fifth index is fourth index. So we have to compare, or we have to make sure that the jth value is respective to I and m value, because we know these two values only. So as we have to find it out the fifth and first difference, so the jth value is m plus I minus 1. Okay, so m is 5, I is 0, right? 5 plus 0, 5 minus 1, 4. So this value is 4. Like this way, we have to find it out the difference between jth value and ith value. Okay, here the jth value is nothing but m plus I minus 1. Okay, and we have to traverse the given ith value till n minus m plus 1. Okay, so till this index we have to find it, we have to traverse. Okay, here I have created visualization for this. This is our first index, this is our fifth index. So we have to find it out difference and we have to store it here. 8 is the difference. The next time the difference is 6. The next time the difference is 8. The next time the difference is 14. So we have to find it out the difference, minimum difference in between these elements. So the minimum difference is 6. Our answer will be 6, right? Like this way we can do simple approach. Here I have sorted the given array. Let's look at the code. I first sorted the array and I have declared the difference and n value. Here one of the scenario is that the value is greater than its size, then we just have to return its 0. Okay, and we can traverse from 0th index to n minus m plus 1. Okay, so for this I have explained again, from 0th index till the index value which is, suppose we have to find it out the difference between last 5 elements. Okay, so these are the our last 5 elements, so we have to traverse till this index only, that is third index, right? So the third index will be respect to ith index is the size of array minus m plus 1. Okay, and we have to just return it out the difference. Here the time complexity for this, as we have sorting it out given. Okay, So this will be n log n, right? The time complexity is n log n, and there is no space complexity, constant space complexity. And yeah, that's it. Thank you.